All right, gang, we're going to graph this function, and I'm just going to go back over what I had done in the previous videos. So the first thing I would do is find the domain. If you have a fraction, you cannot divide by 0. So here, x cannot be 0, because if it's 0, then this is 0, and it cannot be -4. Okay, so for this fraction, it's a number over 0 when it's 0 or -4. So those are domain restrictions. So you want to make sure that you say x cannot be those values. All right, x-intercept, that's where the numerator equals to 0. The numerator will equal to 0 when x minus 1 equals to 0. So x minus 1 will equal to 0 when x is 1. So the x-intercept is 1. I'll write it as 1, 0. This is your x-intercept, and it's odd because you have only one of these. So odd for an x-intercept means that it goes through the graph. Versus bouncing. Versus like looking parabolic there, it's going to look linear in that spot. All right, y-intercept is when you set all the x's equal to 0. So all the x's equal to 0. So 0 minus 1 over 0 squared, 0 minus 4. And that's going to end up being -1 over 0, which is undefined. So that means there's none. Okay, for VA, that's going to be when you have a number over 0. And so basically that's when the denominator equals to 0, but the numerator does not. So the denominator is going to equal to 0 at the domain restriction. So that's going to occur when x is 0 and -4. All right, now you have 0 came from this one. This term is, this factor is squared, which means the 0, 1 is even. And the -4, this is linear. This is the exponent is a 1, it's first degree, which means this is odd. So remember, for vertical asymptote, even means it's going in the same direction. Odd means it's going in opposite directions. And for HA, this is going to be degree 1, which is linear. You have a degree 1, which is linear, over a 2 and a 1, which is 3, a degree 3. This is what we call bottom heavy. Right, the degree of the bottom is higher, which means that you have a horizontal asymptote at 0. All right, so that's all the data gathering, and now you have to put it together. So let me just put up this information that I just found. So my VAs are at -4 and 0. All right, now we said the 0, 1 was even because the exponent was even, and the -4 was odd because the exponent was odd. And what else did we find? We have an x-intercept at 1, 0. And we said that this one was odd, which means it's going to go through. And we have an HA at 0. We know we're going to cross HA because we have an x-intercept. Right, and again, if you guys want to solve that, you would just set the function equal to the HA to see where it crosses, right? So if you set this equal, you cross multiply, you get x minus 1 equals 0, you get x is 1. So you would solve and see where it crosses HA. So crosses HA at x equals to 1. Let me see if we had any other point. Okay, now if you feel like you don't have enough points to graph, which we do not, what you want to do is just get some more information. Okay, so what I want to do is, like, this graph is cut into 3 segments. Do you see that? There's a slice here, there's a slice here, there's a slice here, and there's a slice here, which means there's going to be 3 pictures. All right, so I'm going to figure out what's happening in here. So I'm going to pick a value like x is -1, okay? So I'm going to pick a value like x is -1, and I'm going to plug it into the function. -1 minus 1 over -1 squared, -1 plus 4. So that's -2 over 1 times 3, which is negative 2/3. So that says that the graph is down at -1, it's at negative 2/3. So the graph is down here. All right, now try to remember that you're not going to cross HA, okay? Unless you have an x-intercept, right? So the only places you can cross HA is where the function and HA are equal. So they're only equal in one spot, which is here. So the only time you're going to cross it, which means this guy's not going to cross. Now look, this is capped right here. I can't cross this. So that means that this guy's going to be stuck. This guy's going to be stuck in here like this, because this point, by the way, it could have been any other point. I'm keeping it here because that was the one I found. So you're going to approach the VAs on both sides, and you can't cross the HA unless you have a point where you can cross. You never cross the VA. All right, so now I can draw the rest of it. So this is odd. This VA here is odd, which means that if one side is going south, the other side has to be going in the opposite direction, which is north. So this guy will be up here, like that. Okay, because if one's going south, the other one has to go north. If you plotted a point like -5, you're going to find that it's up here somewhere. I'm rough sketching this. This graph probably comes in a lot tighter than I graphed it, okay? So if you plotted a point here, you're going to notice that it's going to come in tighter than I have it. So let me maybe do that for you. It'll come in tighter. All right, now this guy's even, which means it's going to be in the same direction. So if this guy's going south, then its buddy's also going south. Now I have to touch this x-intercept, but this is odd, which means I'm going to go through. Now this probably doesn't go up very high, but I'm just trying to exaggerate it for you guys, and we're estimating. In calculus, you'll find the exact height of this. It's odd, so it's going to go through, but out here, you have to ride the horizontal asymptote. So that means that at some point, it has to actually come back down like this. So it's going to go up, and then it's going to have to come back down like that. Because as the function goes to positive infinity for x values, the height has to go to 0. And as the function goes to negative infinity for x values, the height has to come to 0. Okay? So it has to, on the ends, approach the horizontal asymptote. It has to approach 0 on the ends. Okay, gang, I hope that helped. I'll catch you. Bye-bye.